Today we're going to be talking about converting to and from moles if you have number of particles. So first we need to talk about what exactly is a mole. So think about the word dozen. A dozen of something is 12 of those things. So if you have 1 dozen cars, you have 12 cars. If you have 1 dozen donuts, you have 12 donuts. A dozen is always 12. Well, a mole is similar. A mole is a number of particles. It just happens to be a really big number of particles. So atoms are tiny, and it takes a whole lot of them to add up to masses that we can weigh on a scale, that we can find the mass on a balance. And so we need lots of them. So we need to know how many things are a mole. Well, 1 mole of anything, and again, it doesn't matter what it is: donuts, cars, atoms, formula units, molecules, whatever it is, 1 mole of them is Avogadro's number. And Avogadro's number is 6.022 times 10 to the 23rd power. That is 6.022. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That many things. So a dozen is 12 things. A mole is this many things. Much easier to write in scientific notation like that. So let's say we have 2.55 times 10 to the 24th atoms of gold. How many moles is that? Well, always start with what we're given. And our conversion factor has to have the same unit as the units we were given. So we were given atoms, so atoms has to go on the bottom so that it will cancel. And we're trying to find how many moles that is. Well, 1 mole of anything is 6.022 times 10 to the 23rd of those things. Now there's 2 ways you can do this. You can do it in your calculator, or you can cancel parts of it to make the problem a little easier to put in your calculator. So since we have times 10 to the 23rd on the bottom, and we have times 10 to the 24th on the top, we can cancel 10 to the 23rd. If we cancel 23 of these, we're left with 10 to the 1st power. Well, 2.55 times 10 is 25.5. Over, we cancel the times 10 to the 23rd, So all we're left with is 6.022 on the bottom. Our atoms unit cancels, so we're just left with moles. Shorthand for moles is MOL, not much of a shorthand. So all we have to do is 25.5 divided by 6.022, and that is 4.234473597 moles. Well, that's ridiculous. How many of those numbers should we keep? So we go back and we look at our original number, and the number of significant figures in a number that's in scientific notation is whatever's in front of the time sign. So 1, 2, 3 significant digits. So we start on the biggest end. We're going to keep 1, 2, 3. We're going to cut it off here. Since that's a 4, we don't have to do anything to our 3. If that was a 5, 6, 7, 8, or 9, we would round our 3 up to a 4. But we don't need to do that. So our answer is 4.23 moles. Let's look at another one. Let's say we are starting with 1.26 times 10 to the 23rd molecules of water. Does it matter molecules of what? No, it doesn't, because we're going from molecules to moles. So it doesn't matter what it is. So we're going to take our 1.26 times 10 to the 23rd, our conversion factor, 1 mole of water on top, and 1 mole of anything is 6.022 times 10 to the 23rd of those things. Molecules, that is not an official abbreviation. I just don't want to write out that big long thing. So we can cancel out, 23rd, I reduced that, I switched that around. So we have given times 10 to the 23rd, and we have divided by times 10 to the 23rd, so those two cancels. The unit molecule cancels, and all we're left with is moles. So we end up with 1.26 moles divided by 6.022, and that equals 1.26 divided by 6.022, 0.20923, etc. And we go back and look at our original. We have 1, 2, 3 digits in front of the time sign. So we're going to keep 1, 2, 3 digits. We're going to cut it off here. That's a 2, so we can just cut it off. So our answer is 0.209 moles of water. Well, what if we're going the other way? What if we have moles and we're trying to figure out how many particles we have, how many atoms or formula units or molecules? So let's see how we convert from moles to number of particles. And remember, number of particles can be atoms, molecules, or formula units. You can think of formula units as like molecules. So an atom would be a pure element, for example, copper. Molecules are held together with covalent bonds, for example, water. And formula units are held together with ionic bonds, for example, table salt, NaCl. But it doesn't matter. We do the problem the same way, regardless of what type of thing it is. So let's say our given is 42 moles. And it doesn't matter which things, so let's do an element. Let's do sodium. We want to know how many atoms is this? So how many atoms are in 42 moles of sodium? So we start with our given, 42 moles of Na. And we need our conversion factor. We have moles on top this time, so we want to cancel. And we know that 1 mole of anything is equal to Avogadro's number, 6.022 times 10 to the 23rd. So our mole unit will cancel, and we're left with atoms of Na on top. So we don't even need the bottom really. We're going to do 42 times Avogadro's number. Again, you can do this in your calculator, or you can take these two and multiply them together. So if we do 42 times 6.022, we get 252.924, and then times 10 to the 23rd. Now, this is not in scientific notation. Scientific notation, we have to move that decimal point 1, 2 places. It has to be between the first 2 digits of the number. So we're going to move it over 2. So we're going to have 2.52924 times 10. It was moved 23. So we moved it 2 to the left. So that's going to be 21. Atoms. And now again, how many of these digits are we going to keep? So we go back up to our original question. We had 1, 2 digits. So we're keeping the 2 and the 5. We're going to cut it off here, and we're going to keep this last part. So our final answer will be 2.5 times 10 to the 25th atoms of sodium. That's our final answer. right, so let's practice a couple. Convert 15.6 moles of BaCl2 to formula units. Formula units just means between the Ba and the Cl there is a ionic bond, and we know this because Ba is way over here on the left side and Cl is way over here on the right side. So when you have a metal with a nonmetal far apart on the periodic table, that's an ionic bond. But it doesn't matter to working the problem. So if we have 15.6 moles, since we're given moles, we want our 1 mole on the bottom, and we want our Avogadro's number on top. So 15.6 times 6.022 is 93.9432 times 10. Don't forget our times 10 to the 23rd. And then we need to see how many to keep. 1, 2, 3, 1, 2, 3. So our answer is going to be 93.9 times 10 to the 23rd. But notice our decimal isn't in the right place, so we need to move that over to 9.39 times 10 to the 24th formula units of BaCl2. Let's look at another. Convert 56.98 times 10 to the 24th. That's bad because it's not in scientific notation. Atoms of, doesn't matter, let's say aluminum, 2 moles. So we start with our given. Since we're given atoms, we know that Avogadro's number of atoms, or anything else, is equal to 1 mole of that substance. Atoms cancels, so we're going to end up taking this number divided by this number. We can cancel out times 10 to the 23rd. So on top we have 56.98 times 10, which is 569.8. On the bottom we have 6.022 left. 569.8 divided by 6.022 gives us 94.6197, etc. moles. So we go back to our original number, 1, 2, 3, 4, 1, 2, 3, 4. We're going to cut it off here, but since that's a 9, we're going to round that up to 94.62 moles of aluminum. I hope this has helped. Please like and subscribe and come back to see other chemistry videos.